an analog I/O control is? How can we perform I/O control function using PLC? So I just want to introduce this. And here you can see what is an analog signal is. So the representation of numerical quantities by the measurement of continuous physical variables. So here analog signal is nothing but it is not having only two states of on and off, instead it is having infinite states. So how can I interface the analog input signal with my PLC? Actually I need an analog to digital converter to perform an analog to digital control. A continuous signal with respect to time which is need to be interfaced with analog input interface that is available at the input module of the PLC, that should be converted into equivalent discrete variable, then that can be given as an input to the PLC. So what are the inputs that can be considered as an analog inputs are flow, cumulative, load cell, potentiometer. These are all the variables commonly called as analog inputs. So and what is the voltage range of common analog input variables are? If you are considering a voltage, the voltage ranges are plus or minus 8 volt, 0 to 10, 0 to 5 or 1 to 5. So if you are taking a current range, the current range is in between 0 to 20 milliamps, 4 to 20 milliamps, or if you are taking a bipolar range, that is plus or minus 20 milliamps. So these are the voltage and current ratings. So what about the analog output? How can I interface the analog output with device with the PLC? I need to send the digital counts, that is of binary values, that need to be connected through analog output interface module. Then that need to be connected to the real board. So what are the current and voltage ranges of analog output modules, which is similar to here analog input module. Similar way, just voltage as well as current classifications which are available. 0 to 10 volt, 0 to 5 volt, 1 to 5 volt. Again, if it is a current range, these are all the ranges. So you have two kinds of voltage as well as current. That is, one is unipolar and another one is bipolar. So if you are giving an input to the PLC as a positive values only, that is between 0 to 20 or 0 to 10 volt, that is a unipolar device. If it is a bipolar, you will be getting both positive and negative. So that's all about some introduction about the analog output variable. These are the analog output devices which can be interfaced. Commonly analog output is if you want to control speed of a particular motor, analog meters, charge recorders, actuators, these are all coming under analog output device. So first what we will do is, we just take an application that we need to perform a analog output control. We just want to perform a speed control. So how can I get the input from the field device, and how can I interface my PLC, and how can I program? So these are all the things we just want to discuss. So here we start programming the PLC. So I need to select the RS logix 500 to perform the same thing. So I am just opening RS logix 500 English for developing our programming. So this RS logix 500 software is for programming micrologix based PLCs. I am selecting a new project. Here I am selecting a PLC called as 1400 series A. So this is the PLC I am showing here. So this 1400 PLC, I need to first configure the PLC from I/O configurations. I am just selecting the PLC. Here I am selecting BXBA configuration. It is base discrete plus base analog input. So I am just applying the changes. So here I am checking the input status. The input slots, input 0, 1, 2, 3, 4, 5 are available. Out of which I can connect 4 analog inputs and 2 analog outputs can be connected with the base module of 1400 PLC. So here input 0.4 slot, here it is showing that micrologix 1400 series analog input 0. So here I can connect input 0, input 1, input 2 and input 3. And next if I am looking after this output, here I can see that what are all the outputs that can be configured as an analog output. Here it is showing that analog output 0 and an analog output 1. So the corresponding addresses are analog output 0.4 and 0.5. So these are all the analog addresses. So now I just want to explain the hardware setup, what is the drive setup which is available, then I am going to develop a programming. So here this is a simple drive circuit. This is a single phase AC motor through which a conveyor is connected. I need to perform the speed control of this particular conveyor. So here I am connecting two proximity sensors. This is proximity sensor 1 and this is proximity sensor 2. So it depends on the sensed values by the proximity sensors. I just want to perform a speed control of this particular motor. So speed control can be performed using this drive. It is called as power flex 40 drive. So this drive is I can perform voltage control as well as current control. So the control output voltage from the PLC is given to this power flex drive. Based on this, the speed of the motor is getting varied. The maximum speed that the motor can run is up to 1330 RPM. So control voltage, I can give a control voltage as well as current. The voltage range is 0 to 10 volt and the current is 4 to 20 milliamps. So for my programming, what I am doing is, I am going to give the current control voltage between 0 to 10 volt. So accordingly, so this is a 1400 PLC. This is a set of analog this is analog input modules. These are all the analog output modules. So what I am doing is, I am just first giving the analog input to the particular PLC. So for that purpose, what I am doing is, I am just developing a programming. So here, my programming is statement is called as SCP, that is called as scale with parameters. Once I am selecting the help menu, I can able to get the information about all the individual blocks of this particular SCP instruction. So what for this SCP instruction is used, I just want to explain. So here, I am just performing an analog IO per control. So what I am doing is, I am just simply performing an analog control, that is, I need to perform a control function. So this is for example a single phase AC motor. This can be operated with the maximum of 1330 RPM. So here I am having a drive. It's called as power flex drive. Power flex drive. So I can give the control voltage between 0 to 10 volt or 4 to 20 milliamps. So what I am doing is, from the PLC, I am going to give the control voltage. So from the PLC I am giving the control voltage between 0 to 10 volt. So what will happen? Based on this 0 to 10 volt, I can able to control the speed of this particular single phase AC motor. So for that purpose, what I am doing is, this AC motor is now connected with the conveyor. So this is a conveyor. So here you are having a proximity sensor PS1 and proximity sensor PS2. So this PS1 and PS2 are the discrete inputs. These two are the discrete inputs to the PLC. Corresponding discrete inputs, I am going to perform the control action over the analog output device. So what I will do is, I am just generating two control functions. One is, if proximity sensor PS1 senses, then speed of the motor is, speed of the conveyor is some 600 RPM. If proximity sensor PS2 senses, then speed of the conveyor is 0 RPM. It means it should not drive. It's what the two simple conditions which I am going to make. So the application which I am taking is, I am giving a discrete input to the PLC and I am just performing the analog output control. So for that purpose, I need to take the inputs from PS1 and PS2. So this proximity sensors which I have connected here are the proximity sensors PS1 and PS2. So this proximity sensor can be operated with 24 volt of DC power supply. So two terminals are given with 24 volt of DC power supply. This is the output from the proximity sensor. This output is connected with the input to the PLC. Again I am taking one more proximity sensor. It's called as proximity sensor 2. Again the same thing which has happened. I need to give the power supply to the proximity sensor. The output is given to the PLC. These two are the discrete inputs to the PLC. So now what I am doing is, what I am doing is initially, so if I am sensing a proximity sensor PS1 that is connected at the input 3, I am connected at the input 3. So based on my condition, if the proximity sensor PS1 senses, then the speed of the conveyor is 600 RPM. So I am just calculating the digital counts of for this particular output. What I am doing is, I am just using a simple move instruction. instruction which is coming under move logical instructions. Here I am taking this move instruction. The source value is I am just giving a constant value of some 2048. So how can I get this input? I will tell you later. So the destination is my output address. So this is my output 0.4 is my output address. So again I am just copying this particular run and I am pasting here. Here input 4. So I am moving, I am not giving any speed at this particular when the input 4 is senses. Here I am giving, this is a proximity sensor 1. It's a proximity sensor 1 and this is input 3 and input 5. It's a proximity sensor 1 and it is proximity sensor 2. So here it is proximity sensor 2. I am just moving a 0 value as the output. So I am just verifying this. I am going to download the program. So I am just downloading the program. So here both the proximity sensors PS1 and PS2 are in sensing mode now. So the proximity sensor PS1 is not sensing. When both inputs are not given, I am just transferring the data digital count to the power flux drive 40. So here is my input 3. For example, if I am sensing this input 3, the data 2048 will be transferred. So here the data 2048 will be transferred. If I am running the conveyor, now the conveyor is running at the speed of some speed. I don't know what is the speed that the conveyor is running. So now, for example, if I am sensing the proximity sensor, I am sensing this proximity sensor, so you cannot get the speed. Now the drive is in idle condition, the conveyor is also in an idle condition, it doesn't stop the condition. So now based on the inputs I am just transferring some digital counts. Now I just want to see what is the digital count is nothing but. So here I am again going to offline to check what is the digital count actually it is. So here I am using an instruction scale with parameters. I just want to explain you what this scale with parameter function is used. So here I am control voltage I am sending to the power flux drivers between 0 to 10 volt. The RPM which is produced by the motor is between 0 to 1330 RPM. So if I am sending a control voltage of 5 volt, then it may be running at almost equal to 600 RPM. So how can I develop this particular control voltage at the output side? So this is the output, that is I am getting output from the PLC. So PLC is now sending a digital counts. PLC is now sending a digital count. So this digital count is nothing but it based on the bit resolution of analog to digital converters. So how it can be calculated with the help of a simple calculation. So here it is showing. So actually I am using this current range as well as voltage range. Here how can I calculate the resolution? Here you can see the bit resolution of ADC as well as DAC is important here. Now what for ADC is used? So just to convert an analog signal into a discrete signal. So here for example I am using a 15-bit analog to digital converter in my PLC. The resolution will be 15-bit and the digital count produced is equal to 32,767. 32,767. So example, if I am taking a 12-bit resolution with a 10-volt signal, then if I am calculating the 10-volt DC divided by the maximum digital count produced by the 12-bit ADC is equal to 4095. The voltage which I am obtaining is 2.4 millivolt. That is for one step increment I am getting 2.4 millivolt. Again, for example, if it is a 15-bit resolution, then 3.5 microvolt is the output for a single step. So here you can see number of bits which are increased in ADC, the accuracy of the sensing input also increases. So again, similarly, here an example is given how to calculate for 12-bit resolution. So if it is a 12-bit resolution ADC analog to digital counter, the maximum digital count will be 4095. The total temperature which you are assuming it is stop. So here for example calculating number of counts per unit using a temperature range of 0 to 100 degrees centigrade. So to determine counts per degree with a 12-bit resolution. So here how can I calculate this value? So how can I calculate this value? So the temperature range is 0 to 100 degrees centigrade temperature for this particular example. In this example, the temperature range is 0 to 100 degrees centigrade. So the voltage which is produced is between 0 to 10 volt. The bit resolution of ADC is here 12 bit. So 2 to the power of 12, we are getting 4096. So the bit resolution, the count value is starting from 0 to 4095. So if the temperature produced by the temperature sensor is 50 degrees centigrade, then the voltage produced by the signal conditioning unit is 5 volt. Accordingly, I can get the digital count as 2048. So similarly, for our example, we just want to perform a speed control. Here we want to send a control voltage of 5 volt at the output side. Then accordingly 2048 will be the digital count which will be transferred at the output side, and corresponding the speed is almost equal to 600 rpm. So we will be getting 600 rpm by transferring the count 2048 value. So that's why I have sent the digital count value of 2048. So here we can get the feedback from the drive. I am getting input to my PLC. Actually, I just want to see what is the speed at which the drive is currently running. To take that, what I am doing is I am getting input. So input 0.4 is the input which I am getting. The minimum input is 0. The maximum in digital count is 4095. Since the base 1400 PLC, Micrologix base PLC is having a 12-bit resolution. So scale to minimum is 0 and scale to maximum is 1330. So output I just want to get a feedback, so I am storing it as an integer value. I am storing it as an integer value. So I just verify input is at 0.4. So verify this project. Download this project. So I am going to online. So here, for example, if now the sensor is sensing at the output 0.4, actually the output 0 is transmitting. So 0 is the digital count which is transferred. So there is no speed produced by the sensor. So what I am doing is I am sensing this particular sensor. So the digital count 2048, digital count 2048 is transmitting. So here you can see the corresponding value, the speed at which get the feedback. So what I am doing is, I connected proximity sensor with PS1 senses. I am going to transfer 2048 as the digital count to the drive. If proximity sensor 2 senses, 0 will be the RPM at which the drive is running. I mean the motor is running. So here I am getting a feedback at the input terminal. Input I call it 0.5. I just want to get what is the speed at which the motor is currently running. So now assume that. So if the one sensor is sensing, now the RPM of the motor is now the RPM of the motor which I am getting as a feedback is 656 RPM. So if sensor 2 is sensing, now you can see the speed of the motor is getting reduced to 0. So this is what a simple application. How can I give the analog? How can I get the analog input through a PLC, that is with a base PLC of 1400, and how can I perform a control action to the analog output terminal? So here the important thing I need to note down is proximity sensor 1, proximity sensor 2 are the discrete inputs to my PLC, and analog output is I just want to perform a speed control of a single phase AC motor through the power flex drive. So to control that particular output, what I am doing is I am giving a control signal from the PLC. The control signal is in the range of 0 to 10 volt. So based on the control voltage given from the PLC, I can able to perform a control function over the speed control of a drive. So through which, if an object is transmitting through this conveyor, so if at a particular point the speed should be minimum, at a particular point if I need the speed should be a maximum, I can perform a control function. Thank you.